The current situation is that after seeing a doctor, a patient may forget the instructions, calls the doctor's office, which may take several days to return a call, and eventually end up in the emergency room with a worse condition. The cost of this problem is in the billions depending on how you frame it. If you frame it as a healthcare illiteracy problem, where the patient does not understand his or her medical condition, then this is a $230 billion problem. If you frame it as a high utilization problem, where 5% of the healthcare population consumes 50% of the healthcare cost, then this is a $500 billion problem. This problem is well recognized by the industry, and several solutions have been implemented. The most basic is a follow-up phone call or text message after a visit. This is limited since it is a one-way communication where the patient is not able to ask questions. The most effective solution is for a nurse, who is familiar with the patient's medical information, to coordinate care. The benefit of such solution has been well documented, with some reducing rehospitalization by up to 30%. The problem with a nurse care coordinator is that there is a limited bandwidth. The human care coordinator can only understand a limited amount of medical history and make a limited number of phone calls. Eventually, the cost of such a solution outweighs the benefit. This is where TeachMeMedical comes in. We superpower the care coordinator by allowing her to supervise a higher number of calls by placing our technology in between the patient and the care coordinator. So going back to our original patient who was rehospitalized because she did not follow her instruction. If you work backwards, she was rehospitalized because she could not get a timely answer to her question when she needed it. With TeachMe she can ask her question anytime when she needs it. This increases compliance with medical directions and reduces complications. Ultimately, the society wins with a healthier population at a lower cost. Currently, our solution consists of uploading and storage of patients' health data stored securely in Google's healthcare services, which is HIPAA compliant. Data can be uploaded as an image, PDF, or entered manually. Before storage, it is de-identified. It is also pre-processed to clean and facilitate the way that doctors process clinical data. When a query is initiated by the patient or through a script, patient's data is queried against validated general medical data, stored in an external vector database, which is then compared to the answer generated in MedLM. In this second layer of answer validation, we use AI agents empowered with tools such as retrieval augmented generation, third-party web search tools, and MedLM. Finally, the answer is presented to the patient through our web application or communicated to the patient via email or text. Our development process is rapid to reflect the feedback that we get from our sample of users, consisting of friends, family, our interns, and patients who have tried our prototypes. Our domain expertise in medicine and development also allows us to reduce the number of steps required for development of new features. Our design philosophy recognizes that AI models change rapidly and anticipate the features that may be available in the near future. Our MVP is functional, and we are in the process of adding full multilingual interaction, channels for communication, and using graph database to derive new insights. Our business model is to work with healthcare systems to augment their care coordinator models to reduce costs and improve healthcare outcomes. Furthermore, we believe that there will be some high utilizer patients willing to pay a subscription fee for concierge-level medical care. Finally, we may also be able to offer our services to other applications in a software-as-a-service model. Furthermore, we have learned that some patients prefer human interactions and will incorporate features for direct communications. However, improvements in real-time AI-generated videos may reduce demand for direct human interactions. Recognizing that chatbots and LLMs are constantly improving, we also try to distinguish our interactions with patients by adding unique value that generic chatbots cannot emulate no matter how advanced they become. An example of this philosophy is the combination of patients' de-identified data with queries to the large language models. Finally, recognizing that regulations are likely to change, we are leveraging large entities such as Google for platform-wide compliance issues such as HIPAA. So far, we have been able to achieve a few milestones. The first milestone was receiving Google's sponsorship to consult with CloudWorks, who helped us to design our prototype with security and scalability to take advantage of upcoming development in AI. The second was our acceptance by Google to use their MedLM models, which is not available publicly, and used by large healthcare systems for beta testing and development. Finally, our MVP has been developed, although new features and bug fixes are constantly being performed. This list of milestones will be updated as we achieve future milestones. We have been able to leverage the multidisciplinary skill sets that our team possesses to develop our product with differentiation. Dr. Paul Lee is an ophthalmologist who specializes in medical and surgical treatments of the retina. He is also a lifelong developer with cross-domain masters in predictive analytics, IT management, quantitative finance, and ethics. Dr. Augustine Lee is pulmonary specialist and an electrical engineer. He is the former chair of pulmonary medicine at Mayo Clinic, Jacksonville, and also a founder of AI and respiratory medicine. Min Lee is a proven entrepreneur who keeps us on track. Noah Jones is a cloud architect overseeing implementation of the project. Finally, Sarah is a UI designer by trade, and Sitara coordinates our student interns. It was our insight that some patients get into trouble, not because they have bad intentions, but because they don't receive answers to their questions in a timely manner that led to the initial development of the project. We were able to achieve this by leveraging our multi-domain skill sets, which will continue into the future with our internal philosophy of constant learning. We recognize that technology changes rapidly in our field and that any solution may become outdated in the next year. That is why we attempt to differentiate ourselves with a unique approach and combine features such as de-identified medical data that generic LLMs cannot possess no matter how many tuning parameters they possess. As we plan for even further, we see our current project only as the first step. Among other possible futures, once various associated technologies have caught up, we envision a future where we are able to create virtual models of ourselves as patients and doctors. In this scenario, our personalized models may be able to interact with various models of doctors and treatments virtually at a large scale before implementing them onto the real patient. Granted that this is one among many potential branches, we keep looking forward to opportunities that better our patients and the society at large. Thank you for listening to our story. We hope that our story will continue to evolve for betterment of our patients and the society. For any questions, please contact us at admin@teachmenow.info.